So, after the discussion of Heisenberg uncertainty principle, the quantum mechanical model and the quantum numbers, let's talk about the shape of different atomic orbitals. Now, taking the shells K, L, M, N, their principal quantum numbers will be 1, 2, 3, 4, right? Azimuthal quantum number will be, for first shell it will be 0 only, as it is 0 to n minus 1. For L it is 0 and 1. For M it is 0, 1, 2. For N it is 0, 1, 2, 3. Now 0 means S, 1 means P, 2 means D and 3 means F. Therefore, these are the subshells, 1 subshell, 2 subshells, 3 type of subshells, 4 type of subshells are present in nth shell. And the subshells are 1s, 2s and 2p, 3s, 3p, 3d, 4s, 4p, 4d and 4f. Now let us see how do they look like. Now this is 1s. There is a nucleus and electron is revolving around it. Somewhere here we cannot tell about the exact position of the electron according to the Heisenberg uncertainty principle. This is 1s subshell. Now this is 2s orbital, little bigger than that. So we have taken these two together to compare, and we can see that 1s is smaller than 2s. If we talk about the p orbitals, if the orientation is towards x-axis, it will be px, it is py, and if it is along the z-axis, it is pz, and they are dumbbelled shape, right? And if we talk about d orbitals, they are double dumbbelled shape. So this is a double dumbbell. Now there are 3 axes, x, y and z. Now you can see that the probability of the finding out of the electron is in between x and y. So the name of this orbital is dxy. Here it is in between y and z. So the name is dyz. And here it is in between z and x. So the name is dzx. There are 2 more orbitals. If the probability of the finding out of the electron is on the x-axis and y-axis both, on the axis. So on x-axis and y-axis both, it will be dx square minus y square. And there is the last one, which is dz square. The probability of the finding out of the electron is on z-axis, and there is a ring around the nucleus which is in the plane xy. So these were the shapes of the orbitals. Now let's discuss some questions. If you solve those questions, this quantum mechanical model, shell, subshell, orbitals, shape of orbital and everything will become very, very easy. Let's solve the first question. So guys, in this question he is saying, represent the electron having the quantum numbers n is equal to 3, L is equal to 2, Ml is equal to plus 1, Ms is equal to plus half. Now we have to represent the electron. Let's solve the question. So the solution, now n is equal to 3. It means that if n is equal to 3, it means it is third shell. So we are talking about third shell, right? L is equal to 2. It means that we are talking about D subshell. So it looks like something. It looks like this. So n is equal to 3, L is equal to 2. Therefore, we will write it is 3D. Okay. Now, writing the value of ml, it will be -2, -1, 0, +1 and +2, right? And what is given? The value of ml which is given, that is equal to +1, and ms is equal to +half, that means is +half. So we can represent the electron like this. So this is the answer. Let's move on to the next question. Now in this question he is asking, in which d orbital the probability density is high on the x and the y axis. Now there are 5 d orbitals: dxy, dyz, dzx, dx square minus y square and dz square. And we know that the solution of this question will be the orbital dx square minus y square, and you can clearly see that the probability density across the x-axis and y-axis is maximum, and on the z-axis there is no probability of finding out of the electron. So this is the final answer. Next, move on to the next question. Now in this question, the set of quantum number is given to you. He is asking which of the following set of quantum number is possible. So whenever this type of question will come in exam, there is a trick to solve it. Now this is a very important question which you will find in NCERT, your package, and any type of a question paper, whether it is school exams or competitive exams. So let's solve it. Now the solution, now what we have to do, we have to compare the value of n, l and ml. That is principal quantum number, azimuthal quantum number and magnetic quantum number. So starting from the option number 1, option 1. Now first of all compare principal quantum number and azimuthal quantum number. Now we know that the value of L, that is azimuthal quantum number, cannot be greater than that of principal quantum number, because the value of L is from 0 to n minus 1. So L will be always smaller than that of n, right? Now in this case what is happening? They are equal. So if n is equal to L, in this case this is not possible. This is wrong. Now going to the next option. So our next option is option number 2. Now in option number 2, principal quantum number is 2, azimuthal quantum number is 3. So L is greater than n. Sorry, this is not possible. That's why this is not our answer. Now option number 3. So if we see the option number 3, in this case n is equal to 4, L is equal to 2. Yes, it is possible because L is smaller than n, and if n is equal to 4 means it is talking about 4th shell. So the shell number is 4. He is talking about the 4th shell, and if L is equal to 2, it means the subshell is D. So he is talking about 4D. Now ml is equal to minus 2. Now we know that the range of ml is from minus L to plus L. So in this case, where L is equal to 2, so for L is equal to 2, it will be from minus 2 to plus 2. From minus 2 to plus 2. So if it is minus 2, that is possible, and spin plus half, that is also possible. It means that this option is correct. And if we see the fourth option, in the option number 4, in option number 4, n is equal to 0. N is equal to 0 means no shell. It's not possible. L is equal to 0 is not possible. So this option is absolutely wrong. So our answer is the third option. So the answer is option number 3. Right? Let's solve some more questions.